Hi, in this video I will be showing you problem number 8 from your class lecture handout on section 11.4. Determine whether the series converges or diverges. Sigma n varying from 1 through infinity, 6 over n divided by 6 to the power n divided by 5 to the power n minus 1. We'll consider this series as sigma an, where an is the nth term of the given series, which is 6 to the exponent n divided by 5 to the exponent n minus 1. So we're going to use the comparison test. If an is less than or equal to bn for all n, and if sigma bn converges, then sigma an also converges. If an is more than or equal to bn for all n, and if sigma bn diverges, then sigma an also diverges. So let's consider here in our problem the denominator of the nth term, which is 5 to the power n minus 1, which is smaller than 5 to the power n. So if we take the reciprocal, which is 1 over 5 to the n minus 1, is more than 1 over 5 to the n. So if we multiply both sides by 6 to the power n, the inequality is unchanged. So 6 to the power n over 5 to the power n minus 1 is more than 6 to the power n over 5 to the power n. Now we are going to consider sigma bn, which is the series to which we are comparing the given series, as sigma 6 to the power n over 5 to the power n. If we rewrite this, it is 6 over 5 to the power n, which can be written as sigma 6 over 5 times 6 over 5 to the power n minus 1, which is geometric series with common ratio 6 over 5, which is more than 1. A geometric series with common ratio more than 1 diverges. So this series sigma bn, which is equal to sigma 6 over 5 to the power n, diverges. And we have a relation here from this step that an is more than or equal to bn for all n, and sigma bn, we just now saw, was a geometric series which is divergent. And therefore by comparison test, sigma an, which is the given series, also diverges. Hope this video helps.